In the last part of this notebook, we will talk about common types of frequency transforms. Those frequency transforms are fundamental in signal processing. We will be using them in multirate signal processing, in the course, in the examples, in our tutorials. And we will start with the discrete-time Fourier transform, the DTFT. So the DTFT is time discrete. So our samples only exist at some sampling time points. We have a sampling interval, capital T. We have a sampling frequency, Fs, that is 1 over the sampling interval. We have infinite signal length from minus infinity to infinity. There is the omega, which is the normalized angular frequency, which is 2 pi times f divided by the sampling frequency. Just remembering that half of the sampling frequency is called the Nyquist frequency. We talked about that before. And it's this transform is continuous in frequency, and it's periodic, so it has a periodicity of 2 pi. And one thing to have in mind is that when one domain is discrete, the other domain is periodic. So we are in time discrete, and that's periodic in frequency. This is also this transform is also invertible, so we have an inverse DTFT. It's given by this formula, and it's very interesting to note and useful that convolution in time domain becomes a multiplication in the DTFT domain, and multiplication is usually much more simple than a convolution. Convolution is mathematically more complicated, and that's the DTFT.